Hello, in this video we are going to open up some downloaded Utah Automated Georeferencing Center DEM data and learn how to mosaic that data into one new digital elevation model raster. So I've already downloaded the data. It's in this folder 2023. And so when you get data, usually digital elevation model data from a source will be zipped together, as most GIS files are, given that they can contain many files often. So good idea to I like to put whatever I'm downloading into a specific folder, then I can just extract those files within that folder, not worry too much about renaming initially until I'm sure what I got. So I'll do that for each of these. Really wants to warn me about am I sure? Extract here. Okay, so as these files are downloading, we can see that they're .ASCII files. So it's a little bit maybe not as common as like a .tiff grid or some other types of DEMs, but should work fine. However, I think some people have noticed that sometimes the kind of the reference for the coordinate system is not tied into this .ASCII format. And so that's why I've downloaded the metadata, which you can see up above, and I saw from there, and I know that most Utah data is delivered in UTM NAD 1983 Zone 12. Okay, so we can see I've extracted each of the ASCII files, and I've got this project open. Oh, some of them are still working. Actually, a couple are still working. So let me just show you in the background here what I have. So I have also a national elevation data 10 meter DEM. That's this big area. And then I have this LiDAR data, which is kind of shown here in a slope map, although the data is sitting there underneath on top of the NED. So once those files are done extracting, I can add them to my map, and then we'll see that they're in pieces. And one other thing to say about them is 2 of the files are 5 meter autocorrelated data. All the autocorrelated DEMs were made from stereophotogrammetry. Some in Utah are 5 meter data. I believe these were constructed in 2007, and others also in 2007 are 2 meter data. And so this area near the town of Stockton in the Lake Bonneville feature of Stockton Bar is both 2 and 5 meter data. And so we should see that. So I'm going to add these in, and we're going to run into some issues, I think. Oh no, it figured out the coordinate system, so that's nice. If it had not figured out the coordinate system, we would have needed to simply define the projection, is what Esri products call it. So these 2 that I just added, I believe, are 2 meter grids. So let's add these other ones. We'll probably see they're bigger. And the LiDAR underneath is, I think it's 1 meter. And this processing is going on over the network, so it may be slightly slow, but they are big files. Okay, so let's see that one. Yeah. that was a big one. So you can see the difference between the 2 and the 5 meter. The 5 meter just swamped everything in the tile size. They elected to make it slightly bigger. And so the reason I got the 2 different data sets is, you know, all this kind of covers the Stockton Bar in pieces. And maybe the 2 meter only exists in certain areas. I'll put that up above. And so where it is available, we might like to have that higher resolution. But other parts is only 5 meter, but maybe we could, since it's all made from 2007 air photos, it should represent the landscape somewhat similarly in time. And so we're going to mosaic these together into a new raster, but given that we have overlap, we'll have to make some decisions about that. Okay, so these are my 4 data right up here, so I'll highlight them. We could simply kind of rename them. So that's the 5M North, we'll call it 5M North. I think this will be 5M South, just for reference. And then this one is the 2 meter south. And that one's 2 meter north. These are not really renaming, it's just renaming the label in my project, as most of you likely know. Okay, so I'll click off of there. Oh, I have now identified something. Okay, so let's mosaic these into one new raster, which preserves 2 meters where it is, and then covers this whole area. Later, we'll then and this will be in a separate video, we're going to kind of clip all of this area to the area of the LiDAR for direct comparison. But for now, I'll put that down there. Okay, so what we want to do is go to Analysis Tools, and the mosaic tool that we want is, if we were going to search for it, we would say mosaic to new raster. But I always think it's useful to click on the data on the toolbox over here, so you kind of realize where that is, because there might be other similar tools to choose from. And so you can see that it sits within data management tools under raster, raster dataset, mosaic to new raster. So we'll open that up. And so now I can just pick the ones that I want. So I want each individual piece of the AGRC stereo photogrammetry DEMs. And so I need to save it somewhere. I'm going to save it locally so that I don't get issues processing over the network. Sometimes it fails. So I may need to add a new connection here. Let's see about that. Now let's see, it's going to let me put it into this PC, my documents, and can put it in here as like, we'll just call it practice. And then that's our folder location. So we go back to practice, click it. Sometimes they ask for a folder location and a raster dataset with a name and extension. Other times they kind of do it all in one for many of these geoprocessing tools. I guess it depends on when the tool was written and by which coding teams it was written by. Okay, so give this an appropriate name, AGRC DEM 2_5M, and I like .tiffs. In the spatial reference, we should be able to grab from one of the other files here. It's interesting that some of them are unknown, but they've figured out where they lie. So we're going to choose the NAD83 UTM zone 12 because I know that's what it's supposed to be. So one key thing when you're mosaicing to a new raster is that you really need to choose the pixel type correctly. In this case, these are digital elevation models. The value of data in the pixels is elevation, and it's in meters. And so generally it's going to have about 4 digits on to the left of the decimal, but it does have decimals. So we need to have decimals. And if we look at pixel type here, the default tends to be 8-bit unsigned. You can click on this info button, and we can see that 8-bit unsigned means values of 0 to 255, like a digital number for a photo that you might take with your phone. That's not going to cut it, and so we can see that we need something with decimals. And as I look through here, the first option that has decimals appears to be 32-bit float. And there are some more options down below, but we want the smallest file size with decimals, and that'll be here. So the cell size, that's an interesting question. So here we have both 5 meter and 2 meter data coming in. I guess I can over-interpolate and go with 2 meter cell size output to try to capture it as best we can where it is. There'll be repeat values in neighboring pixels where it's 5 meter data and being mosaicked. So it'll all look like 2 meter data in the end, but there'll be some kind of low slope areas. Okay, so number of bands. Bands is just the number of types of data stored within each pixel, and here we just have elevation. So the number of bands is 1. If we were dealing with photos, it would be red, green, blue. That's 3 bands. And then, so here's a key. So the mosaic operator. So we're gonna, since we have kind of some areas of overlap, and I made sure to put the input rasters of the 2 meter up above. So those are our first file, and so we want to prioritize that. And so yeah, so that should do it. So I think that will prioritize the 2 meter in areas of overlap. But let's see if there's anything we needed to do in the environments. We do want to build pyramids, resample. I don't think that we need to do that. Okay, I'm going to go ahead and run it. Okay, looks pretty smooth. So if I change the colors, we can kind of see where it fits within the rest of the data. So I'll do that. Whoa, this is big. Okay. So there is my AGRC nested within this larger NED, and then the little piece of LiDAR is somewhere in there as well. I'll throw that on top. So we just saw how we could basically combine these bits of 2 meter with 5 meter into one mosaicked new data set at a new 2 meter resolution. Okay, so this was our tutorial on mosaicing rasters to a new data set. Remember that you need to definitely choose the pixel type and fit it to the type of data you're dealing with. You need to know the number of bands you're dealing with, which is just the types of data stored within each pixel. For DEMs, it's always 1. And then selecting the cell size. If you leave that blank, it'll go with whatever was fed in as the first operator. Okay, so there is our result. Hopefully that helps.